A city does not end at street level. The visible city is only the top layer. Even the road is a carefully engineered sandwich. Below it, every utility wants the same address. Water mains deliver pressurized drinking water across the city. Pumps, reservoirs, and elevation keep that pressure available. A small leak can quietly remove enormous quantities. A large leak makes its announcement more clearly. Used water begins a completely different underground journey. Most sewers rely on gravity whenever geography cooperates. Where gravity fails, lift stations continue the trip. Many cities keep wastewater and rainwater in separate systems. Older cities may send both into one pipe. Heavy rain can turn that convenience into overload. Storm drains work well until the entrance becomes salad. Some cities store huge storm flows below ground. Cameras and robots inspect places humans should avoid. Grease and wipes can create impressively expensive geology. Gas networks may also occupy the shallow underground. Digging here rewards accuracy and punishes improvisation. Underground cables distribute electricity without overhead lines. Vaults contain switches, transformers, and serious warning signs. Fiber cables carry the city's invisible daily conversation. One excavator can accidentally create a digital holiday. District energy networks can distribute heating or cooling underground. In some cities, steam still travels beneath streets. Utility tunnels organize services and allow easier maintenance access. Easier does not mean spacious, dry, or comfortable. Deeper down, transport begins claiming much larger spaces. Some tunnels are built using cut-and-cover construction. Others are bored underground without opening the whole street. Concrete lining rings support the ground behind the machine. Stations are underground buildings, not simple holes. Ventilation controls heat, airflow, and emergency smoke. Pumps are essential because tunnels dislike becoming canals. Escape routes connect deep infrastructure back to daylight. Much maintenance happens during short overnight access windows. The morning timetable rarely mentions the underground surgery. Some stormwater tunnels pass beneath nearly everything else. Underground reservoirs can protect streets during intense storms. Buildings also send their structure into the ground. Heavy towers may require foundations extending far below street level. Basements must resist earth pressure and unwanted water. Waterproofing is cheaper before the basement becomes an aquarium. Retaining systems keep nearby streets and buildings in place. Engineers monitor settlement, vibration, groundwater, and structural movement. Before digging, teams try to map what already exists. Old records sometimes contain more confidence than accuracy. Radar and electromagnetic tools help locate hidden utilities. Careful test holes confirm exactly what the instruments detected. Then the ground introduces the city's previous versions. Urban construction can uncover foundations, objects, and forgotten streets. Some waterways were redirected, covered, and largely forgotten. Disused tunnels may remain beside modern infrastructure for decades. Cellars, vaults, and old chambers complicate apparently empty ground. The local residents generally refuse to share their records. Cities often stand on layers of fill in earlier construction. Groundwater continues moving through the soil and rock. Deep excavation may require temporary groundwater control. Poorly managed pumping can contribute to damaging ground movement. Long-term groundwater extraction can make entire urban areas subside. Leaks can wash away soil and create hidden voids. Eventually, the surface discovers the missing support. Every city's underground depends on its local geology. Ground conditions can transform the same design completely. Industrial history may leave contaminated soil and groundwater. That material must be tested, managed, and treated safely. The subsurface can also provide heating and cooling. Even trees need underground space for roots and water. Unfortunately, roots and aging pipes have different objectives. Modern networks increasingly use sensors to detect problems earlier. Better digital models can reduce future underground surprises. Shared corridors could make maintenance less disruptive and chaotic. Future cities may even move goods beneath congested streets. But every new system competes with everything already there. Underground planning is three-dimensional engineering with permanent consequences. The city's costliest surprises are often already installed. Thousands of hidden systems require constant inspection and repair. Above ground, the city looks almost effortless. Underneath, an enormous machine keeps everything above it working. Like the video, comment, and subscribe.